Hello, welcome to my tutorial video related to the final assembly for the class MET 240 Learning Inventor, Learning Autodesk Inventor. So if you go to the book and open a page 1229, you will see how to start the main assembly. Make sure you have all the parts in one folder before that. So I'm here and I have here the project file like subassembly, and there I copied all my folder. So if I go and select project, also I can say new single user project, and you have to make sure that whatever your parts are, in my case that's in MET 240, and I can either select the one that I have. So if I say browse, and if I go there, I already have final project, and if you don't have that, create that one, or mechanical tiger, that will be one of the options. So once you do that, then let's start assembly. You go to metric, standard, create, and I'll call this, I'll say save as, and I'll call this final assembly. Mechanical tiger. And you please add your first name and last name. And the first part that we will add inside is the chassis part. If you remember, we were doing the chassis part. So I will say place, and then I will browse for the chassis part. B2 chassis, that's the part, and I will say open, and here all you have to do is to click summary. We don't need a second one, so you can either hit escape or right click OK. And once you did import the chassis, say right click and then change the grounded option, because the first base part has to be fixed, so make sure you fix it. Just say grounded, and after you have the pin there, you're good. And now we'll change the view visual style to shaded with edges. And then if you take a look at the page 1230, you will see the second one, the second part that will be added will be the real axle support. So it's A12 real axle support, this one. And I will say open, and I will place it somewhere. If they're both the same color, it's kind of hard to see, so it will be nice. I would change mine just to some other color, so you know that they're not overlapping. So in this way, basically we're adding this, and I would do the free move just to have easier accessibility when I'm selecting it. So basically this one should be flipped with free rotate just a little bit like this, so I can easy select. Basically I would put this one over there, so I would say constrain and use the default one, which is mate, assembly mate, and mate. So you see two different planes are facing each other and they're parallel, and the offset in between them is 0. So I'll select the vector here and the other one here. And after I did that, I just want to show you that basically I didn't specify location. It can be anywhere. And then the next one will be, I would like to add axis here. So I will say constrain. But before I do that, I would just like to check the distance in between these two. So I'm adding the new axis in each one of these holes, and also on the other part that I just added. And if I go to inspect and say distance, and before I do that, I would like to say dual unit. So you see I have millimeters, so let's make inches as my second unit, and I will say the distance in between these two axes, something I cannot remember, so I like to use the snipping tool just to capture, because there's too many digits there. And then I will measure the distance in between these two other ones, and then I will pull up my snip just to compare them. So you see they're the same, so we shouldn't have any issues here when we're assembling. So I will say assembly, constrain, and then I will add axis to this axis. So I align two axes, and look what happens, like this. And then I will align the second axis. So I will say this hole should match wherever this hole is. And in this way I have two fully constrained parts. So if I do escape and I try to move this one, nothing will happen. And then you should hide the work axes because you actually don't need them once you finish this. So just say right click visibility. I can select the first one with a shift, the last one with a shift. So I selected all four of them. Right click visibility. And we can flip it just to see it's the same thing as you have in the book on 1230. So the following part will be the gearbox right part. So I will say gearbox right, gearbox right, here you are, open, and I will put it somewhere here. And I'll go to the book just to see how it should look. So basically in the page 1232 you can see where it should be. So check the tail. Tail should be down like this. And basically it's not going to stay like that, so I will do a little bit of the free rotate just to show you it. At the end it will be more like this. So if I do free rotate, just align it a little bit better like this. So basically I will position this one on top of that. So the first one I will do will be put this surface on top of this surface, and still it can go anywhere. Second one will be, I will position it like this, you see hole on the hole. And the third one I will make the parallel to surfaces. So in this case I have to select one axis and zoom in, flip a little bit until I get the one here. And then I just want to show you, the more constraints I add, this is no longer the free body in space. You see now it has only 1 degree of freedom, which is this rotation. And basically to remove this degree of freedom, I would like to add here constraint, which will be parallel. So I will do constraint angle, and I will do the undirected angle. So I zoom in, I select this plane and this one here. And after I did that, I have 3 fully constrained parts. And it's very, look, I have save reminders, so make sure you save. So it's very important to have 3 parts that are completely fixed. So just try moving them, and if you cannot move them anywhere, you're doing good. So next, when we add all these motors or gears, we will do fine with the animation. So the next one will be, we will add the motor part. So we will say place, and we will go and try to find our motor here. And let's check in the book how it's going to be oriented. So basically the motor will be more, did I pick the right one? Now I'm just wondering. Gearbox right, did I have to put the right, just a second, I have to check, am I on the right side? Okay, these two are at the right side. And then my motor, you can see how it's positioned on the page 1235 and the page 34. And the really good picture is 1236. There you see how you're going to put it. So basically I will do the free move just to show you before I do assembly how it's looking. So maybe here, and if I do the free rotate, something like this. You see it will be facing this way. So again I will start with the constraint that I have made. So let's see, which one did I use? Or maybe let's use the one we didn't use before. So let's try this one, flush. So I'll say flush, And I would say that you see this surface here will be at the same place with this other one, and they would be parallel, and you don't see it yet, but you see what I'm doing, like they're like in the same plane. And then you'll see better when I apply another one. I will say here axis. So I mean I can close this and make constraint. I'll get default selected. Basically I say here axis and here another axis, you see. Okay, so what's happening now, look how my motor is turning like this, and I also have to have it fixed. So basically I will use the same trick with angles. So I will say constraint angle and the one in the middle undirected, and I can say okay, I want you to be facing same way as maybe this plane. You can select any other parallel plane. So looking this way, I have fully constrained motor. So the next I will move on to the gears, and that will be really fun after I do this one. So basically I will add a gear. So the first gear will be G0 pinion, and I really can just move to details, type, so it's easier for me to select it. G0 pinion, because you see here they have numbers, so I will put it there, and I only need one. And again, for my gear, I will use the same align option. So you see it's mate, but I switch to the flush, and then I will select outside plane and outside plane here, apply. Then the second one I will go back to the mate, and I will say I want to do the axis to the axis of this hole. Okay, so what do I have right now? I have a gear which right now can just move around this axis, which is very, very good for my future animation, but really cannot be moving like this all the time. So I will have to turn on the plane on my motor and turn on the plane on the gear, and I will define the angle in between them. So that would be my driving component. So if I open the motor, let me see which one, and I open the origin, and this plane is fine. So I can use either YZ or I can use XZ. Let's use XZ, like what they used in the book. So I will say right click, visibility, because I need to select it. And for my Spur gear, let's use the plane from there. Okay, let's do this one. So now I have two planes. One is from the gear, the other one is from the motor. And the gear will be turning around the motor. So I'll have to define a new constraint in between them. So if we go to the page 1237, you can see there the place constraint. So we will say the angle in between these two. So I will say angle, and I'll select one plane, the other plane. So you see now when it's 0, they're parallel, but I want to do 45. 45, because I would change that later. And I say okay. And let me show you what's happening. So you see I have here angle 3, which is under the motor, and it's also defined under the Spur gear, any of these two. So if you go to the end and look what happens. I have angle 45, and I will say right click drive, and I'll change 45 to 410. And if you hit play, we actually animated the gear around the motor. That's exactly what I wanted to do. So try one more time, plane, where I'm going reverse. So you see basically my axis is my center of my polar coordinate system, and I define a second polar coordinate, which is the angle in between the gear and my motor, which is really good. And I can hide planes. I don't need to see them anymore. Okay, visibility. And then the following one will be the short spacer. So if I go here and find short spacer, I can put it there. And then I will add this constraint, mate and short spacer. It doesn't really matter which plane I select because it's symmetric. I will select this, and then I will add another one, which is axis. And really it doesn't matter, it's actually spinning around, but it doesn't matter because you know, it doesn't have any distinct features, so we don't see anything else there. Then the next one would be the gear G1. So I'm going to place gear G1, and I'll put it here. So first constraint, I always like to put this constraint mate from here to here, apply. And I like to use free move just to take it a little bit out so it's easier to select what I want to do. So I want to do the axis on the other axis, like that. So basically I added two of them, and look, it can still spin. But what I want to do right now, so again, one of my polar coordinates is good. I have the axis, and I have that plane which is blocking where this gear is. But now I would like to add another one. This is a brand new constraint that we didn't do before. I want to identify the motion in between them. So I will say motion, and it will be 0.2 ratio. And forward, the first one, and then it will ask me to select cylindrical surfaces. So I will zoom in, select this one outside, and I'll zoom in here and select this one here. And if I say, in here I think I have to do the first, so again 0.2. the outer surface of the G1 and outer surface of the G0. And let's see what will happen when I do the, so if I go back to 45 and I say drive, and if I hit play, look, now they're moving, one gear is moving the other one. So that's fine. So now we will keep adding gears, and just make sure you're saving this motion in between them. So I'm going to the page 1241, and now it's saying add another short spacer. So I will say, okay, oh, I'm sorry, constraint, no. I will say place, give me another short spacer, open. Here, and again I will say plane to this plane, and I will add axis to axis. Okay, that's what I need. And again, let's do save. I don't know, every time this pops out it always stays. I don't know how to remove this segment there. So now I'm going to add the G2. Spur gear, here you are. And again, same constraints. It went so far away. Okay, this plane goes here on my short spacer, there. Apply. I cannot select short spacer, so I will just take this out. And I didn't change constraint, this is just visually for me to make selection. So I'm saying axis on axis, okay. And now let me check my angle. So if I go to the angle, drive, play, something is wrong with this guy. It wouldn't move, it looks like it's too big. You see, it's kind of, I mean, oh, I'm sorry, it's moving. Okay, so I'll check dimension later, but yeah, I didn't add constraint motion, so I will put motion, And ratio, what's the ratio? Is it the same? I guess it is. Oh no, it's different. 0.286, and then I'll use this second one and the first one here, and again we will select the outer surface of G2, second one there, and the outer surface of the G1. Okay, and then I check my drive, right click, drive, play. So they're doing good, they're good. So you see I have one more gear. So here it says place gear, this is the G3 here, and when I say plane here, and I'll just do the free move outside. And also here. And again, it can move, but it's not related. You see these two are moving together. So I guess here again I have to add the drive. So I will do the constraint motion. This second one, ratio is 0.286. The first one is selected, and again I will do the last one I added and the one I had before. Okay, and let's check the drive angle, right click, drive, play. So far so good. Okay, so that would be, I think the video is getting long, so I might stop here, and then later you will have other stuff starting from 12:45. I think I will end here this video and then just continue, just do 2 videos from, because it's kind of getting long. I don't know if I can upload it to YouTube and Blackboard if it's too long. Okay, so check another one later for other parts.